Let's welcome to our YouTube channel Physics for UG. So in this video, we shall discuss Maxwell's thermodynamic relations. And these relations are very important in thermodynamic study. Similar to, there are so many equations in thermodynamics, but Maxwell's equations are very basic equations and which can be applied in many things, in many applications in thermodynamics. So first of all, what are these equations? They are a set of equations in thermodynamics which are derivable from definitions of the thermodynamic potentials. हमारा चारों पोटेंशियल से इंटरनल एनर्जी, एंथैल्पी, हेल्महोल्ट्ज फ्री एनर्जी and gas free energy. From these four potentials, we derive four Maxwell relations. So from U we get the first equation, from F we get the second equation, and from Z we get the third equation, and from H we get the fourth equation. This is very important. You have to remember the order and first, second, third, fourth for how to derive these equations. First of all, look at this point. These relations are statements of equality among the second derivatives of thermodynamic potentials. पोटेंशियल को क्या करेंगे, पोटेंशियल को हम सेकेंड डेरिवेटिव ले जाएंगे और सेकेंड डेरिवेटिव के बाद हम उसको इक्वलाइज करेंगे. इक्वल करने के बाद हमको जो इक्वेशन मिलेगा हम इसको मैक्सवेल इक्वेशन बोलेंगे. तो कैसे याद रखेंगे? फर्स्ट इक्वेशन कहाँ से आएगा, सेकेंड कहाँ से आएगा, थर्ड कहाँ से आएगा, फोर्थ कहाँ से आएगा. देखो, अल्फ़ाबेटिकली एनर्जी का मतलब, एनर्जी का सिंबल यू होता है, कहीं जगह पर एनर्जी का सिंबल ई भी होता है. लुक द अल्फ़ाबेटिकल ऑर्डर, ई, देन एफ, देन जी, देन एच इन द लास्ट. ई एफ जी एच, ई फॉर एनर्जी, एफ फॉर हेल्महोल्ट्ज फ्री एनर्जी, and G for gas free energy, and H for enthalpy. So in this order, E, F, G, H, the first, second, third, four relations can be obtained. So let's discuss one by one and derive one by one. They are very simple methods, very simple techniques. You can easily derive the equations. Remember the order: U, F, G, H. U for first equation, F for second equation, G for third equation, and H for fourth equation. Okay, chilling. Next part. Let's see. This is the first. Now derive the first Maxwell's thermodynamic relation. So the first equation is from U, internal energy, for the expression du equal to Tds minus Tp. This is derived from potential function. You can watch my video in the potential part. That's why du equal to Tds minus Vdp. What is du? So if S is constant, S is constant, then ds equal to 0. Then what will happen? Then du is equal to minus Pdv. That implies minus P is equal to del u by del v at constant S. ये तो हम डिराइव किए थे फर्स्ट पार्ट में. ओके, नेक्स्ट पार्ट इज इफ v इक्वल टू कॉन्स्टेंट देन dv इक्वल टू 0, then du is equal to Tds. That implies T is equal to del u by del S at constant V. Now these two equations, this is the first equation and this is the second equation. Take derivative of these two equations from both sides. So in the above part, in the first equation, in the this equation, it is written minus P equal to del u by del V at constant S. So take derivative with respect to S both sides. So from equation 1, we take derivative, differentiate with respect to S. So what will get? Minus del P by del S, del P by del S at constant V is equal to, right side में del by del S, same part del by del S del U by del V at constant S तो नहीं लिखा जाएगा क्योंकि डेरिवेटिव विथ रिस्पेक्ट टू x होता है. सो क्या होगा? del square U by del S del V. सिमिलरली क्या करेंगे? इक्वेशन 2 को डेरिवेटिव करेंगे, डिफरेंशिएट. इक्वेशन 2 क्या है? T इज इक्वल टू del U by del S और कांस्टेंट V. सो अब डेरिवेटिव करेंगे दिस इक्वेशन को विथ रेस्पेक्ट टू V करेंगे क्योंकि राइट साइड में S होता है, V नहीं होता है. डेरिवेटिव V करेंगे. इक्वेशन 2 differentiate with respect to V. So what will happen? Left side part del T by del V at constant S is equal to del by del V of del U by del S, that implies which is equal to del square U by del V del S. Look at this is equation number 3, this is equation number 4. तो इक्वेशन 3 और 4 में राइट साइड पर इक्वल होता है. ये जो del square U by del S del V and del square U by del V del S both are same. If RHS part is same, so LHS part will be same. So from equation 3 and 4 we'll get minus del P by del S at constant V is equal to del T by del V at constant S. So this equation is the first Maxwell's relation. Okay, I will give you a shortcut trick how to remember these 4 equations, how to remember these 4 potentials. So you just, this is the mathematical derivation, how to derive the first relation. Now let's see the next part, how to derive the second Maxwell relation. Now as we discussed, the second equation can be derived from F because first part is from U, first part from U, next part is from F, next part is Z, and next part is H. So second will be from F. Okay, what is df? Df equal to minus S dt minus P dv. Df is the Helmholtz free energy and S is the entropy, T is the temperature, P is the pressure, and V is the volume. Now derive this for the Maxwell relation. How to derive that one? Second equation. So on this part, if same process, if temperature T equal to constant, then dt equal to 0, then what will happen? Then df is equal to minus P dv. That implies minus P is equal to del F by del V at constant temperature T. This part is temperature T constant. This take as equation number 1. Similarly, if next part is if volume V equal to constant, then dV equal to 0, then what will happen to df? Then df equal to minus S dt because dV part is 0. That implies minus S is equal to del F by del T at constant B. This is equation number 2. Now we have to differentiate equation 1 and 2. That is cross differentiating. क्रॉस डिफरेंशिएशन का मतलब क्या होता है? ये जो फर्स्ट पार्ट लिखा है, ये जो फर्स्ट पार्ट में वॉल्यूम होता है, टी होता है, तो दिस पार्ट को हम डेरिवेटिव करेंगे. इक्वेशन 1 को हम डेरिवेटिव करेंगे विथ रेस्पेक्ट टू टी एंड इक्वेशन 2 को हम डेरिवेटिव करेंगे विथ रेस्पेक्ट टू वी. सो दैट इज कॉल्ड क्रॉस डिफरेंशिएशन. ओके, नाउ क्रॉस differentiating equation 1 and 2. What will get cross differentiation? That will be minus equation. Look at the first equation, equation 1, minus del p by del t at constant v is equal to same part del by del t del f by del v. बिकॉज इक्वेशन 1 में राइट साइड में v होता है, डेरिवेटिव v होता है, तो इसीलिए हम डेरिवेटिव विथ रेस्पेक्ट टू t के, that is equal to del square f by del t del v. Similarly, for the equation 2, derivative will be with respect to v, that will be minus del s by del v with respect to t is equal to del by del v of del f by del t. So this part will be del square f by del v del t. Now this is equation 3 and this is equation 4. Now equation 3 and 4 are equal, right side part is equal, so left will be equal definitely. So what will happen? So the next equation from equation 3 and 4 we get minus del p by del t at constant v is equal to minus del s by del v at a constant t. So we can write both side negative sign cancel out, so the result will be del, like this one, del p by del t at constant v is equal to del s by del v at constant t. This one is the Maxwell's second thermodynamic relation. This is second equation that derived from F part. Second equation derived from F part. Now discuss the third relation, which will be derived from Gibbs function z. Now we shall derive the Maxwell's third thermodynamic relation. Third relation. So first one is from U, next part is from F, next part G, and next part H. So this time we shall derive from this part G. So what is G? G is the Gibbs function potential minus S dt plus V dp. Okay, the first part, if temperature T equal to constant, that implies dt equal to 0. So what will happen? So the equation will be dg equal to V dp, that implies V is equal to del g by del p at a constant t. The first part, this is equation number 1. Similarly, the next part is if t is constant, so taken t constant and next is p constant. If pressure p equal to constant, that implies dp equal to 0. So what will happen? dg equal to minus s dt, that implies minus s is equal to del g by del t at constant pressure. This is equation number 2. Now next part similar to other two. Now cross differentiating. Now cross differentiating equation 1 and 2. क्रॉस डिफरेंशिएशन मीनिंग क्या होता है? इक्वेशन 1 में डेरिवेटिव राइट डेरिवेटिव विथ रिस्पेक्ट p होता है, तो हम डेरिवेटिव t के तरफ करेंगे, और इक्वेशन 2 को डेरिवेटिव विथ रिस्पेक्ट t होता है, और we shall differentiate this second equation with respect to pressure P. So what will happen? So for first equation, look at the first equation. The derivative is already with respect to P होता है राइट साइड में, so हमको T पे करना है डेरिवेटिव. So del V by del T at constant pressure दोनों साइड में, del by del T of del G by del P. So the equation will be del square g by del t del p. This is equation number 3. Similarly the second equation को डेरिवेट करेंगे with respect to p, because राइट में t होता है इसलिए p को करेंगे, that is minus del s by del p with respect to p at t constant is equal to del by del p of del g by del t, which is equal to del square g by del p del t. This is equation number 4. From 3 and 4 equations the right side part are equal, so left will be equal. So what will be the expression from equation 3 and 4? We get del v by del t at constant pressure is equal to minus del s by del p at constant temperature. This equation is the third. This equation is the third Maxwell relation in thermodynamics. Clear? Now let's move to the next part. There is the fourth Maxwell's relation. Now let's derive the fourth Maxwell relation. The fourth equation, this is the fourth equation, can be derived from dh, because as per our rule u is the first, u, then f is the second, g is the third, and h is the last. So this one is the fourth equation we have to derive. Okay, so at the formula dh equal to tds plus vdp. Okay, h is a function of s and p. If s equal to constant, that implies ds equal to 0. So what will happen? So dh will be equal to vdp, that implies v is equal to del h by del p at a constant s. This is equation number 1. Also in the second case, if other part means p equal to constant, then dp equal to 0, then dh, if dp 0, then the remaining part will be dh equal to ts. Look at the top equation, that implies t is equal to del h by del s at a constant p. This is equation number 2. Now what will happen? Now we have to cross differentiate. Now cross differentiating equation 1 and 2. We get cross differentiation meaning in the first part डेरिवेटिव राइट में विथ रेस्पेक्ट टू p होता है, हमको विथ रेस्पेक्ट टू s करना है, और सेकंड में विथ रेस्पेक्ट टू s होता है, हमको विथ रेस्पेक्ट टू p करना है. तो क्या होगा? फर्स्ट में लुक एट द फर्स्ट इक्वेशन. डेरिवेटिव हमको क्या करना है? विथ रेस्पेक्ट टू s करना है, क्योंकि डेरिवेटिव विथ रेस्पेक्ट टू p होता है वहाँ पे. सो del v by del s at a constant p is equal to del by del s of del h by del p at a constant s. No need to write the constant. Okay, that is equal to del square h by del s del p. This is equation number 3. And the second equation we have to differentiate with respect to p, because सेकेंड इक्वेशन में वहाँ पे डेरिवेटिव विथ रिस्पेक्ट टू s होता है राइट साइड में, तो हमको p पे करना है डेरिवेटिव. तो क्या होगा? del t बाई del p एट कांस्टेंट s इज इक्वल टू del बाई del p ऑफ del h बाई del s, which is equal to del square h, double derivative del square h by del p and del s. This is fourth equation. Look at equation 3 and 4. These two equations are equal from right side. Del square h by del s del p, and 4 equation में del square h by del p del s. Del p del s both are equal. So left part will be equal. So this left side part will be equal. So from 3 and 4, so from equation 3 and 4 we get del v by del s at a constant p is equal to del t by del p at a constant s, or we can write del t by del p at constant s is equal to del v by del s at constant p. Same equation, but I just exchanged left to right and right to left. This is the fourth Maxwell relation in thermodynamics. So the derivations are very important. Easily you can derive the four equations. So by using, so let me summarize first of all. By using u, f, z and h, the u for first equation, f for second equation, g for third equation, h for fourth equation, u, f, g, h, these four thermodynamic functions give four Maxwell relations in thermodynamics. Okay, next part, let's discuss how to memorize these four equations. This is very important and these are very difficult to memorize, and I'll give you a shortcut trick so that you can easily remember the Maxwell equations. Now let's discuss how to memorize the Maxwell's relations. How to memorize these four equations are very, very important and very, very difficult to remember, because S, P, T, V, that can be interchanged, that can be placed anywhere. So first thing, remember the process. Surest process to verify. Surest means S, entropy. Process means P, T, V. Surest process to verify, that means this is the surest process to verify Maxwell's equation. Surest process to verify. This is my technique, surest process to verify. So how to write? So let's try the first equation, first Maxwell equation. So start here, remember the line, surest process to verify. So write first surest process to verify. Move in clockwise. Surest process to verify. So put del everywhere. Del. Put del everywhere. Del. Then give line, this line. Put bracket. So लेफ्ट साइड में मिडिल में इक्वल दे दो, लेफ्ट साइड में एस होता है तो वहाँ पे वी लिख दो, बी होता है वहाँ पे एस लिख दो. तो ये फर्स्ट इक्वेशन, फर्स्ट का मतलब ये जो ऑड नंबर होता है, ऑड का मतलब इसमें एक माइनस साइन लगा दो. द डेल पी बाई डेल एस आर कॉन्स्टेंट वी इज इक्वल टू डेल टी बाई डेल पी कॉन्स्टेंट एस. दिस इज द फर्स्ट इक्वेशन. So started from this bottom part, this part is starting point S. So in second equation, so start from the next upper part position. So this is surest process to verify, clockwise. Go to shift, one position is shifted. So लगा दो del S, del लगाओ ब्रैकेट, हो गया. सेकेंड टी, वहाँ पे वी करना है, वी वहाँ पे टी करना है. दिस इज द सेकेंड इक्वेशन. एंड थर्ड इक्वेशन स्टार्ट करो नेक्स्ट पोजीशन में. दिस इज surest प्रोसेस टू वेरीफाई. डेल लगा दो, डेल लगा दो, del by equal to by. The third equation, this is odd number, so put negative sign. This is third equation. So totally fourth equation. This is next position में start करो. surest process to verify. del लगा दो, इक्वल में इक्वल साइन, उसके साथ ये होगा S, ये होगा P. These are the, you can check, these are the four Maxwell's equations. You can easily remember. So how to remember? So first part, this will be first equation this will be starting point, and for second this will be starting point, and for third this will be starting point, and for fourth this will be starting point. So the process is process to verify, and easily you can remember these four equations, and these four equations are very crucial and very important in thermodynamic applications while deriving the next part Clausius-Clapeyron equation, or in CP equations, TDS equation, and in all these applications these equations are very important. So you have to remember these equations. By using this process you can memorize Maxwell relationships. Thank you. If you like the video, then like the video and then subscribe my channel. Thank you.